Good afternoon, everyone. So today we'll try to study the module 5 from the analysis of determinate structure. As we all know that because of the coronavirus, so we are on holidays. So let us try to practice this type. Today we'll have a trial of that one. If you get any doubt, you can contact to my number. So we'll start with the fifth module. Fifth module deals with the arches and the cables. Okay, so in arches there are three types of arches. One is three hinged arch, and the second one is two hinged arch, and the last one is zero hinged arch, and it is also called as fixed one. So two hinged and fixed arches are the indeterminate structures. They are the indeterminate structures. So three hinged arch is an determinate structure. So in this module we will be dealing with the three hinged arches. In three hinged arches we will be dealing with two types. One is parabolic type and one more is parabolic type and one more is circular type. So in parabolic type, here we need to calculate few things. Like for a parabolic type, let us first draw a three hinged arch. So here we have a support where we have a hinge one, and the third one will be at a crown. Crown is the point which is the highest point of the arch. So this we denote it by H, and this is the span of the three hinged arch L. So if I consider a point here, so let us take this as it is acting at a distance x, and this height, let it be y. So we will name this as ABC, right? So now to calculate this y in a parabolic method, we have 4 into h bracket lx minus x square whole divided by L. So from the figure you can come to know what is L, what is h, and what is x, right? L is the span of the arch, h is the rise of the arch, and y is an height at a distance x. Here it is from the support left, right? So this is y is equal to 4h into Lx minus x square. So now the resultant reaction, this R is calculated by the hypotenuse formula, that is h square plus v square. And from this we can say theta is equal to tan inverse v by h, right? So, and with this we will be calculating normal thrust, which is given by n is equal to v sin theta plus h cos theta. Along with this we will be calculating radial shear. So this radial shear is denoted by Q, which is calculated by v cos theta minus h sin theta. So these are the things which we have to remember. The one thing that we should remember here is the bending moment at A and the bending moment at B and the bending moment at C in a parabolic type. Because of a hinge, it is 0. So that we have to remember. And we will be finding the bending moment at particular given points. So now let us consider a simple problem. In this type, in a question paper, they will be just giving a question and the diagram or the parabolic arch you have to draw. So here we have a question. Right? Let us consider this. Here once I will read the question, go through that. A 3-hinged parabolic arch of span 24 meter, rise 6 meter, with hinges at abutments and at crown point. It means that a 3-hinged arch of span 24 meter means L is given, which is 24 meter. And other than that, they have given that rise is 6 meter. So this is called rise, and that is H. So H is equal to 6 meter is given. Along with that, he says hinges at abutments and at crown point. It means 2 supports, 2 abutment. So 2 and 1 at 3 means it is a 3-hinged arch. Other than that, in a question paper, it's given that arch subjected to a point load of 50 kilonewton and 150 kilonewton. So 2 point loads are acting. So 50 kilonewton L1 and 150 kilonewton L2 at a distance of 8 meter and 20 meter from the left support. So it means that there are 2 points acting on this 3-hinged arch. Let us take L1, which is equal to 50 kilonewton. It is acting at a distance of 8 meter from left support. And there is one more load which is acting on this, that is L2, 150 kilonewton at 20 meter from, once again it is an left support, from left support. So here it is asked to find out, here he has given determine reactions at support, resultant reactions and its inclination at supports, and he has asked to draw the bending moment diagram. Along with that, he has asked to find out the normal thrust and radial shear at a distance of 6 meter, both from left and from right. So we have to find out normal thrust and radial shear at a distance of 6 meter. So it has to be calculated from left support and also from the right support. These are the things given. So just check here. The span is 24 meter. Rise is 6 meter. The first load 50 kilonewton. It is acting at a distance of 8 meter from the left support and 150 kilonewton at 20 meter from the left support. So we'll sketch for this. So this is the diagram. Here we have an support. Let us name this as A, B, and the given span is 24 meter, and rise, the highest point is 6 meter. Here there is an hinge, so this is called 3-hinged, and he is saying if I consider a span here, so it will be like at this point 50 kilonewton is acting, which is at a distance of 8 meter, and one more load is acting 150 kilonewton, which is at a distance of 20 meter from the left support. So this is what he has given. So first thing we have to find here is the reaction at the support. So there will be an horizontal reaction and then vertical reaction at A and at B. So let us calculate HA, HB, VA, VB. So let us consider sigma MA is equal to 0. So we know that how to find out the reactions, right? So when I say sigma MA is equal to 0, here you can see that HA is, the line of action is passing through the support. So the HA into perpendicular distance, which is equal to 0, gives you a moment as 0. And VA, the vertical force, vertical reaction Again, the line of action is passing through the A, which means that the perpendicular distance is 0. So now we are left with 50 kilonewton, 150 kilonewton, HB and VB. So let us write for that. Sigma MA is equal to 0. Let us take clockwise as positive. So 50 kilonewton is acting downward. It creates a clockwise movement, force into perpendicular distance, which is 50 into 8. So again 150 kilonewton is acting downward, which generates a clockwise. So it is 150 into the distance is 20 meter, right? So HB, the line of action of this HB passes through the support A. Therefore, the perpendicular distance is 0. So HB into 0 is 0. So one more is VB. VB is acting upward, which creates an anti-clockwise. So anti-clockwise is minus VB into the perpendicular distance is 24 meter, which is equal to 0. So from this we get the force, the VB. So if you have a calculator with you, you can calculate. Presently, I will be writing the answer directly, which is equal to 1.474167 kilonewton. And we know that sigma Fy is equal to 0. Let us take upward forces as positive. It means that Va plus Vb minus 50 minus 150 is equal to 0. So from this we get Va, which is equal to 58.33 kilonewton. If I write sigma Fx is equal to 0, then from the above diagram we have only two forces, HA and HB. So HA minus HB is equal to 0, which says that HA is equal to HB. So now we are supposed to calculate either HA or HB. So let us consider sigma MC is equal to 0 and also clockwise as positive. Here you can consider either left portion or a right portion, that is half of the portion. So let us consider the right portion, that is this portion, right? So when I consider that portion, the diagram will be like this. So here we have a support, here is ground C. Okay, let us write this. This is VB, HB, and at this point there is a load acting, which is 150 kilonewton. When I write sigma MC is equal to 0, it is acting downward, so it creates an 150 into. Now how to calculate this perpendicular distance? So we know that from here to the load is 20 meter. Right? So C acts at the center, that is 12 meter. 20 minus 12 is, how much it is? 20 minus 12 is 8, right? So 8 meter. And then VB is acting anti-clockwise, so minus VB into half of the distance is 12, and then again HB, which is clockwise, HB into height, the rise, this height is 6 meter, it's given, which is equal to 0. Therefore from this HB is equal to, when you calculate that, you will get 83.34 kilonewton. So we know that HA is equal to HB, therefore HA is equal to 83.34 kilonewton. So this is how we are supposed to calculate the reaction. So as I said earlier, the bending moment at A, the bending moment at A, the bending moment at B, and the bending moment at C will be 0 because of the hinge support. So now let us calculate the bending moment at 50 kilonewton and bending moment at 150 kilonewton. So before that, let us calculate or get a general equation for Y. As I said, Y is calculated by the formula Y is equal to 4H into Lx minus x square whole divided by L. So in this problem, the rise is given as 6 meter. Let us make it as general equation 24x minus x square divided by 24. So what happens? 6 into 4 is 24, 24, 24 get cancelled. 24 square it is. So 24, 24 get cancelled. 24x by 24 is x. And then minus x square by 24, which is equal to 0.0416 x square. So the general equation for this problem to calculate y is equal to x minus 0.0416. Now let us calculate bending moment at 50 kilonewton. Bending moment at 50 kilonewton. So at 50 kilonewton means the 50 kilonewton load is acting at a distance of 8 meter, which means this is x is equal to 8 meter. Now let us substitute that in the above equation. Y is equal to 8 minus 0.0416 into 8. So therefore y will be equal to 5.33 meter. So to calculate the bending moment at this point, let us take that as D. This is A, where we have HA, VA, and this height is equal to 5.33 meter, and this is acting at a distance of 8 meter, right? So now we will calculate the bending moment at 50 kilonewton. Bending moment is equal to, so HA we have calculated already. HA is equal to 83.334. So this is acting upward. It creates an clockwise. If I take clockwise as positive 83.34 into this perpendicular distance is 8 meter, and HA is acting like this. It creates an anti-clockwise minus 53.34 or 33 into the height. Just a minute. Reaction is 53. Sorry. Bending moment is calculated as HA. The HA is 83.33, right? So 83.34, which is anti-clockwise, minus into the perpendicular distance here is 5.33. VA is clockwise, and the value of VA is 58.33, and this distance is 8. Right? Now from this equation, calculate the bending moment at 50 kilonewton, which you are going to get as 22.44 kilonewton meter. In the same way, we are supposed to calculate bending moment at 150 kilonewton. Bending moment at 150 kilonewton. So bending moment at 150 kilonewton. So it's given here that 150 kilonewton is acting at a distance of 20 meter from left. It means that 4 meter from right, because the overall span is 24 meter, right? So if I take only the right side portion, it is like this. You have VB and then HB, and then at a distance of 4 meter you have 150 kilonewton. Let us take this as E. So the general equation for y is equal to, it is the general equation, y is equal to x minus 0.0416 into x square. So now substitute for this one, y, x. So 4 get y is equal to 3.33 meter. So this height is 3.33 meter. Now to calculate the bending moment at E or at 150 kilonewton, we'll have an equation like this. That is 141.67 into 4, VB into 4, and then VB, it is acting anti-clockwise, so minus, and then this one HB is acting clockwise, so it will be 83.34 into 3.3. So you get bending moment is equal to 289.37 kilonewton meter. Okay, so this is bending. So we were supposed to calculate the resultant and the angle at which it is acting. So to find out the resultant, let us consider this diagram. So this is HA at A, this is VA, and this is resultant R. Let us consider this is angle A, theta A, and this is A. That is with respect to support A. So from the hypotenuse theorem, we know that RA is equal to HA plus VA squares. So HA, substitute for HA and VA, that is 83.34 square plus 58.33 square. From this formula, we get RA is equal to 101.73 kilonewton. In the same way, we know that theta A is equal to tan inverse of VA by H, which is equal to tan inverse of VA is, what is the value of VA? VA is 58.33 and HA is 83.34. From this, we get theta A is equal to 34.99 degree. In the same way, when we consider for support B, this is VB, this is HB, and the resultant will be here RB, which makes an angle theta B. So in the same way, apply the hypotenuse theorem at B, you get HB square plus VB square, where RB is equal to 83.34 square plus 141.67 square. Therefore, RB is equal to 164.37 kilonewton. In the same way, theta B is equal to tan inverse of 141.67 divided by 83.34. From this, we get theta B is equal to 59.53. So after this, they are asked to draw the bending moment diagram. So let us draw a bending moment. So this is a 3-hinged parabolic arch. Here we have a support. At this point, we are supposed to, at a distance of 4 meters, we have a bending moment of 22.44, and at a distance of 20 meters, we have a bending moment of 289.37 kilonewton meter. So now just to join these two points as an arch to C, because the bending moment at C is 0 and at B is 0. So this is the bending moment diagram. So once we draw the bending moment diagram, let us name this A, B. This point is C. Once we draw the bending moment diagram, we have to calculate the normal thrust and radial shear. In the question, it's given that we have to calculate the normal thrust and radial shear at a distance of 6 meters from left and also from the right. Let us consider from left side. So here what we have to do is, we all know that tan theta is equal to dy by dx, and in this we have a general equation for a dy, which is x minus 0.0416 x square. So first differentiate this one. So we know the method of differentiation. Dx by dx is 1 minus, take this constant outside. So the differentiation of x square is x raised to n into x raised to n minus 1. So that is 2 into x raised to 2 minus 1. So we get an equation, or we get a value of this as 1 minus, multiply these two. So the answer will be 0.0832 x. So this is tan theta. Now it's given that we have to find out normal thrust and radial shear at a distance of 6 meter. It means that substitute x is equal to 6. Then calculate tan theta. Tan theta is equal to 1 minus 0.0832 into 6. So from this we get theta is equal to 26.60. So we all know that we have a formula for a normal thrust n, which is equal to v sin theta plus h cos theta. Right? So here we have an equation. We have to calculate v sin theta plus h cos theta. So n is equal to, so what happens when we say 6 meter, here we can see at a 6 meter we have VA, HA. So this is a point, let us consider this as F, which is at a distance of 6 meter. The 50 kilonewton is acting at a distance of 8 meter. It means that here we have only one vertical force and one horizontal force. So when I say that V, then we have to consider VA, which is equal to 58.33 sine the angle is 26.6, plus in the same way H, which is equal to 83.34 into cos 26.6. Therefore from this we get n is equal to 100.64 kilonewton. This is normal thrust. In the same way we have a formula for a radial shear which is given by Q, which is equal to V cos theta minus H sin theta. So substitute for that. We already know what is V cos and all. Just substitute for that. You get an answer for radial shear. So from this equation we get Q is equal to 14.81 kilonewton. This is from support left. So here you can see the formula. We have V sin theta plus H cos theta, and here it is V cos theta minus H sin theta. So in the similar way we have to calculate normal thrust and radial shear at 6 meter from right support. So now let us consider from right support. When you consider the right support, here again you have VB and then HB. 6 meter from right you have 150 at distance of 4, and also now we'll have V. Here one more point where you have to calculate. Let us call this point as G. So which is at a distance of 6 meter. So now if I calculate for this, theta remains same because the distance is same, that is 26.6, right? 26.60. So the theta remains same in that equation. So now you are supposed to calculate V and H. Since H is a single force here in the horizontal direction, HB, which is H, is given as 83.34. And we are supposed to calculate V now. So V is 150, which is acting downward, and then plus VB. So VB we have calculated already. What is the value of VB now? The VB is equal to 141.67. From this we get V is equal to minus 8.33 kilonewton. Because in this portion the 150 kilonewton is acting at a distance of 4 and we are calculating normal thrust and radial shear at a distance of 6 meter. So 150 kilonewton is acting downward in this particular portion. So now we will calculate normal thrust. So the formula for normal thrust is V sin theta plus H cos theta. So V is minus 8.33 into sine. The angle remains same because of the same distance, but support varies. So H is 83.34 into cos 26.6. Therefore, N is equal to, calculate for N, you get 70.78 kilonewton. And radial shear is V cos theta minus H sin theta. So substitute for that, minus 8.33 into cos 26.6 minus 83.34 into sine 26.6. So from this you get Q, which is equal to minus 44.78 kilonewton. So this is how we have to calculate normal thrust and radial shear in the 3-hinged parabolic arch. Thank you. If you have any doubt, you can contact me. We will discuss in a group and try to use the calculator. Don't by heart anything. Thank you.